Morning students. So today let's start the new topic, three-phase system. Okay. So our soil mass consists of solid particles and it will forms or it will creates a porous structure to the soil mass, and the voids in the soil mass, voids or pores in the soil mass may be filled with air or with water or by both. Okay, that is, in general a soil mass consists of solid particles, then air and water. So these three constants are blended together to form a complex material. So that is known as three-phase system. In three-phase system, that is in soil mass, there will be solid particles, water and air, and these three constants are blended together to form a complex material. Okay. But even though the soil mass is a three-phase system, it becomes two-phase system in some of the situations. That is the first case. And is if the when the soil is fully saturated, there will not be air, there will not be air phase, that is the voids are completely filled with water in the case of fully saturated soil. Okay, that is, as I have told, in three-phase system there will be solid particle and voids, and the voids may be filled with air or water, and in fully saturated case these voids will be completely filled with water, there will not be air. Okay, that is first case of two-phase system, that is fully saturated soil. And another case is when the soil is absolutely dry, the water phase will disappear, that is the voids are completely filled with air, there will not be water. Okay, so here also there is only two phase, that is solid and air, that is if the when the soil is absolutely dry. Okay, so this is about three-phase system and two-phase system. So normally the soil will be in three-phase system, that is the soil mass consists of solid particle, water and air, and these constants are blended together to form a complex material. And in some special case there will be two-phase system also, that is in oven dried condition and also in fully saturated soils. Okay. Next we can discuss about phase diagram or block diagram. That is, I have told that the soil mass consists of solid particle, water and air, and these three constants are blended together to form a complex material. However, for convenience, all the solid particles are segregated and placed in the lower layer of the three-phase diagram. Likewise, water and air particles are placed separately as in this figure. Okay, that is, the three constants cannot be actually segregated like this. In practical, these three constants cannot be actually segregated like this, but a three-phase diagram is it's actually an imaginary concept for easy understanding and convenience for calculation. Okay, so phase diagram or block diagram means, for the purpose of study and analysis, it is convenient to represent the soil by a phase diagram, with part of the diagram representing the solid particle and the part representing water or liquid and another part air or other gas. So this is a block diagram or phase diagram. That is, for the convenience of study and calculation, we have segregated these three particles like this. That is, in the lowermost part it is solid, and above the solid there will be water phase, and in the top there will be air phase. But in actual condition the soil is not like this. All these three constants are blended together to form a complex material. But for simplicity of analysis and calculation, we have arranged these three systems or three phases like this. So this is known as block diagram or phase diagram. And this block diagram is extremely useful for studying the various terms used in soil mechanics and the interrelationships. Okay, from this block diagram, we are going to discuss so many definitions on soil engineering and the interrelationship between these parameters. Okay, so this is a three-phase system or block diagram, and this is partially saturated soil, that is the voids are filled with partially filled with water and partially with air, and there will be solid. And in fully saturated case there will be only two phases, that is the voids are completely filled with water, there is no air in the fully saturated condition, that is there will be solids and water. And in fully dried soil, the water is escaped from the system, so the voids are completely filled with air, there is no water since it is dried soil. Okay, so these are the different cases. This is partially saturated soil, there will be three phases, and fully saturated soil there will be solids and water, and dry soil there will be solids and air. Okay. So this is the block diagram. So This is the actual arrangement, that is on the right side we are representing volume and left side it is representing weight. That is weight is the total volume. Okay, that is total volume of the soil system, and VV is the volume of voids, and this is solid, so the volume of solid says Vs. So total volume is the sum of volume of voids plus volume of solid, and this volume of void is equal to volume of air plus volume of water. Okay, that is voids are filled with air and water. So volume of void is equal to volume of air plus volume of water, and total volume is equal to this volume of voids plus volume of solid, or total volume is equal to volume of air plus volume of water plus volume of solids. Okay, likewise in the left side we are representing weight. This is the total weight, and total weight is equal to weight of voids plus weight of solid, and weight of voids is equal to weight of air plus weight of water. So all of you know that weight of air is 0. There is no weight for air. So weight of voids means weight of water only. So weight of total weight is equal to weight of solid plus weight of water. Okay, so this is a three-phase system, and from this three-phase system we are going to discuss how many terms which is used in soil mechanics and the interrelationship between these terms. Okay, so first we can discuss about volumetric relationships, and these are the volumetric relationships which are widely used in soil mechanics. First one is void ratio. So void ratio is represented by the small letter E, and void ratio is equal to volume of voids divided by volume of solid. Okay, that is we have told that volume of void is represented as VV, that is volume of void divided by volume of solid. So this is volume of solid, and the ratio of volume of void and volume of solid is known as void ratio and is represented by E. Okay, next is porosity. It is represented by the small letter N, and porosity is equal to volume of void divided by total volume of the soil sample. That is porosity is volume of void divided by total volume. Okay, that is void ratio we are expressing in volume of solid, that is volume of void by volume of solid, but porosity is ratio between volume of void divided by total volume, that is we are expressing porosity for the total volume of soil sample. Okay, so this is very important, void ratio and porosity. Next is degree of saturation, and it is represented by S, capital S. Okay, that is degree of saturation is the ratio between total volume of voids containing water, that is volume of water divided by volume of void. That is we are representing degree of saturation, that is how much water is present in the voids. That is, as I have told, the voids are filled with water and air, and the parameter which represents the volume of water within that total volume of void is degree of saturation. Okay, that is degree of saturation S is equal to volume of water divided by volume of void. So if the soil is dry, what will be volume of water? That is, if the soil is fully dry, there will not be water in the void, so volume of water will be 0. That is, in the case of dry soil, degree of saturation is 0. Okay, and in fully saturated condition, this volume of void, that is voids are completely filled with water, that is volume of water will be equal to volume of void. That is this degree of saturation will be 100%. That is, for fully saturated soil, degree of saturation is 100%, and for dry soil it is 0%. So this value of degree of saturation varies between 0 and 100%. Okay, that is for dry condition it is 0, and for fully saturated condition it is 100%. Okay. Next we can discuss one weight relationship, weight ratio, that is water content. So here we are going to discuss the weight ratio, that is left side it is representing weight. So water content represented by small letter W. Water content is the ratio of weight of water to the weight of solids. Weight of water to weight of solid is water content, represented by small letter W. Okay, this is one of the important weight ratio. So next we can discuss about volume weight relationship, that is soil unit weight. That is the volume weight relationship are in terms of unit weight, and the weight of soil per unit volume is known as unit weight or specific weight. Okay, so we can discuss about important unit weights in soil mechanics. First one is dry unit weight. So dry unit weight is defined as the weight of solids per unit total volume. Weight of solid per unit total volume is dry unit weight. Okay, that is, it will be for the soil which is dry condition. So weight of solid divided by total volume is dry unit weight. Next is total wet, bulk or moist unit weight or bulk unit weight. It is known as bulk unit weight, represented by gamma. Okay, and this bulk unit weight is defined as the total weight per unit total volume. That is, total weight of the soil divided by total volume of the soil is bulk unit weight. So total weight of the soil means weight of solids plus weight of water divided by total volume of soil, weight by volume. Okay, so in the case of bulk, it is the ratio between total weight of soil divided by total volume of soil. But here dry unit weight, there will not be water in the dry condition. So that is W of W, that is weight of water, will be 0 here. Therefore it is weight of solid by weight of weight of soil divided by total volume of the soil is dry unit weight here, because in the dry case there will not be water, and in the bulk case there will be air, water and solid, and weight of air is 0. So total weight means weight of solid plus weight of water divided by volume is bulk unit weight. Okay. Next is saturated unit weight. That is considering degree of saturation 100%. So here volume of air will be 0. So saturated unit weight is the weight of soil solids plus water. Weight of soil plus weight of water divided by total volume of soil. That is saturated. That is, saturated unit weight is the bulk unit weight when the soil is in fully saturated condition. Okay. And next is submerged unit weight. Submerged unit means when the soil exists below water, it will be in submerged condition. That is, if the water table is above the soil will be in submerged condition. So there will be a buoyant force acts on the soil particles, and according to Archimedes principle, the buoyant force is equal to the weight of water displaced by the solids, and the net mass of the soil is reduced, and the reduced mass is known as submerged mass or buoyant mass. So the submerged unit weight is equal to saturated unit weight minus unit weight of water. Okay. The derivation is not required, and I will explain this in later. That is, submerged unit weight is the difference between saturated unit weight minus unit weight of water. Okay. So this unit weight of water, what is the value of unit weight of water? Gamma W is equal to 9.8 kilonewton per meter cube. So, okay, this unit weight of water you have studied in your fluid mechanics. Unit weight of water value 9.81 kilonewton per meter cube or 10 kilonewton per meter cube. Okay, and in if it in Newton per meter square, it will be 9810 Newton per meter cube. Next parameter is specific gravity. Okay, specific gravity means the ratio of weight of solid particle to the weight of an equal volume of water at 4 degrees Celsius. That is known as specific gravity. It is the ratio of weight of solid particle to the weight of an equal volume of distilled water at 4 degrees Celsius. That is, we are comparing the weight of any particle with respect to that of water. So the physical property is known as specific gravity, represented by capital G. Okay, that is, specific gravity of a certain material is the ratio of unit weight of that material to unit weight of water. That is, we are referring with respect to water. Okay, unit weight of that material divided by unit weight of water at 4 degrees Celsius is known as specific gravity. Okay, the specific gravity of the soil is often needed for various calculations in soil mechanics. In every calculation, almost every calculation, the term G will be coming. So specific gravity is actually constant for different types of soil. Okay, and it is a unitless parameter because it is a ratio of unit weight of that material to the unit weight of water. So it is dimensionless parameter, and specific gravity of water is taken as 1 and that of mercury 13.6. Okay, and specific gravity of different soil. The specific gravity of soil actually varies between 2.6 to 2.8 like that, and for sand it is 2.65 to 2.67, and silty sand it is 2.67 to 2.7, and for inorganic clay it is 2.7 to 2.8, and soils with mica or iron it is 2.75 to 3, and organic soil it is less than 2. Okay, and in problems, if it is not given, we have to assume the value of specific gravity as 2.67 or 2.7 or 2.8 like that. Okay, so the specific gravity is one of the important physical property of soil, and the specific gravity is usually tested using the material pycnometer. It is a glass bottle. Okay, that I will discuss later. So we have discussed some of the fundamental definition, that is void ratio is the ratio of volume of void divided by volume of solid, and porosity volume of void to total volume, and water content, that is a weight relationship, weight of water by weight of solid, and degree of saturation, volume of water to the volume of void. And there is another definition, that is air content. It is the ratio of volume of air to volume of void. Okay, so this air content is actually 1 minus degree of saturation. That is, degree of saturation means volume of water by volume of void. Okay, so volume of air content, that is, if we are adding air content plus degree of saturation, AC plus S will be equal to 1. Okay, because volume of air plus volume of water is volume of void, so volume of void by volume of void, that will be equal to 1. So air content plus degree of saturation is equal to 1. So air content can be represented as 1 minus degree of saturation. Okay, these are fundamental definitions. So it is very important. You should read the textbook and by heart these relationships. Okay, so after that we can go to the next portion. Okay, you should thorough about these definitions. So today's video is over. Thank you.